So what we are going to start now is very important. So far, you have been developing program with only one variables like x equals 1, I equals 2. So these are the values that you are storing in one variable. But we have some more complex data structures in our programming languages, like list or arrays. Okay? So always remember this thing, that whatever arithmetic operations you perform, whatever instruction you write to perform arithmetic operations, they are all executed in registers. Okay? So if you have a data stored in memory, when I refer to memory, always remember that I'm referring to an external memory. Okay? So register is also a memory. What is the size of this memory? Registers? 32 bits, and how many locations? 32 locations. We can say that it's 32 times 32 bit memory. Okay? This is small size memory. We cannot store our big data like videos, images, etc. Okay, so we always have off-chip memory, which we commonly refer to as the main memory, where our main data is stored. So sometimes you need to read, for example, the Excel sheet, okay, and perform some calculations on it. So that data is stored in main memory. It is first retrieve the data one by one, and then put it in the register where the arithmetic operations are performed, and then we can store it back to the place wherever we need it. Okay? So always remember, in RISC-V processor, and many other processors are now based on the RISC-V architecture. So arithmetic operations are always performed in registers. Yeah.
Can you go over those steps again? You said you first retrieve the memory, and then what was after that?
Yeah, so if we have to perform some arithmetic operation on a data which is stored in memory, so what we need to do is to access the memory, read the data, and put it into the register first, and then perform the arithmetic operation. And then we can either keep it stored in the register, or we can put them back into memory, depending on what is the instruction. We will see some examples. Okay? So to apply arithmetic operations on memory contents data, we need instructions. So we have seen instruction of performing arithmetic operations like add, logical operations like AND, and control operations like BNE, BEQ. Now we need to access the data from memory. So there are two instructions. One is referred as load, and the other one is referred as store instruction. When we talk about load instruction, so load instruction means we want to load the data from memory to register. Okay? Do not get confused, because many of you get confused with what does load do and what does store do. So load means loading the data from memory to register. Although both are memory, register is also memorizing the data. I would say it's also storing the data, but generally we refer it as register, and memory is considered as an off-chip memory. Okay? So load means loading the data from memory to register, and storing means storing the data from registers to main memory. Okay? So memory is byte address. Each address identifies an 8-bit byte, and as I mentioned, that 32 bits address space corresponds to 4 GB, which is equivalent, and 64-bit 4 GB means 2 to the power 20, and 16 XB byte corresponds to the 64-bit address space. We are not talking about 64, so our discussion will be restricted to 32-bit address space. Okay, so suppose we have a word array named A, and it is starting from some address referred as x9000. Okay, and the value of this address is stored in S1. Now try to imagine that we have already talked about list. How is the data in list arranged in Python? Can anyone recall? All the data in a list are placed in consecutive memory locations next to each other. Okay, and if we have to remove or edit the element, we need to perform some shift operations that is internally performed by Python. Okay, we do not need to do that. But what I'm trying to say here is, suppose we have a big memory, and when I'm saying that we have an array A containing some elements, this array, so out of this entire memory, A may be placed somewhere in the memory. Okay, somewhere means like we have some images placed here, videos, and something else, and let's say A is placed over here at this point. Okay, so where A is starting from in the memory is generally referred as the base address of A. Okay, and A may contains a couple of elements, let's say 2, 4, 6, 10. All these values are represented as bytes, different bytes. Okay, now how can I refer to this value in array or in list? I can write A, and this is 0, 1, 2, second index, right? So whenever we need to address data in a memory, we need to specify first the base address where the value where the actual array A is starting from in the memory. We do not know, maybe this is 0, and this is 4, this is 8, and maybe this may be considered as 9,000. Okay, so this is the base address, and after the base address we have to specify the next thing is, so this is 0, 1, 2, 3, 4, and so on. So we need to specify the offset. Okay, so for example, if I have to access this value, I would specify, I'm telling you the actual value in terms, but we need to specify in terms of number of bytes. So here, for example, this is the 0th index value, 0, 1, 2. So we need to access this value as A2. So this offset would be 2. Okay, but this is exactly not equal to 2. You will see we have to specify in terms of the bytes. Okay, it should be multiple of 4. So I have just sketched this diagram out just to have you an idea of, like, out of big memory, if we have to access some array or list or container, we need to specify the base address, where do we want to jump in the memory, and then offset helps us reach to that particular element, any particular element. Okay, okay, let's go back to slides. So, and in the load address memory, load and store instructions, we need to specify the address. So first of all, A0 is starting from 9,000. We assume that this 0th location is 4 bytes wide, which is one word wide. Okay, so 32 bits wide. The next A1 is placed at 9004. You understand? And then 8, and then 12, which is represented as C in hex. Similarly, 10, which represents 16. Okay, so that's why the number system, understanding number system, and having a command, full command of how the numbers are represented in hex is very important. Okay, so this, for example, at this location, this value, which is a decimal value, which is the actual data, would be placed something like this. So 9,000, so this first byte here would be 9004, 9005, 9006, 9007, and then 9008 is corresponds to the another word. Okay, so this 100 is here represented as a hex value, which is equivalent to 64. Okay, and all the other 3 bytes have 0 values. It does not matter. So we can actually represent a 32 bits data in memory as well in each location. Yep.
Can you explain at element A4 how is 9, 10 is 16?
So it's represented in hex. This is what I was saying, that it is important to understand the hex representation. You see 0, the next would be 4, value would be 4, the next would be 8, and then if you add 4 further in 8, it would become 12, and you can represent 12 in C as C, right? And then what would be the next value? 16. And how would you write 16 in hex? In hexadecimal format. How do you write 16 value in hex? So you write it like, so 1, 2, 4, 8, 16. So you set, and if you were to write it, it will be like hex. Okay, so this is why this is 9010. Okay.